The charged particle in figure below moves east, as you see here. It experiences a force that acts out of the page. Does the particle have a positive charge or a negative charge? So it is out of the page, so it is going to be like that, the force. So we need to use right hand rule. Right hand rule, thumb is showing the velocity direction. 4 fingers showing the B direction, and palm showing the force direction. So if we keep thumb toward velocity and 4 fingers going in Z direction, so it means that force is gonna come out of the page. So it follows the right hand rule. It means that we are dealing with a positive charge. If it was going into the page, it was negative charge. Next example, it says a charged particle moving along a y-axis passes through a uniform magnetic field oriented in the z direction. Magnetic force acts on the particle in the negative x direction. Does the particle have positive or negative charge? How would the force change if the charge of the particle were tripled but the velocity were halved? So that's y direction, z direction, and x direction. It says it's moving in y direction. That's the velocity. Magnetic field oriented in z direction. And magnetic force is going to be in negative x direction. So in the previous example, we said it's going to come out of the page, but this one is going to go into the page. So it means that we are dealing with a negative charge particle. And it says, how would the force change if the charge on the particle were tripled but the velocity were halved? What's the relationship between magnetic force and magnetic field strength, velocity, and charge of the particle? This is the formula we have. Sine theta is going to be 1 because they are perpendicular. B and V are perpendicular, so it's going to be sine 90, and sine 90 is 1. So if we make the charge tripled, it means that this one is going to be 3 times bigger, so force is going to be 3 times bigger. But the velocity is reduced to half of it, so it is going to be 3 times half, it's going to be 1.5. So the new force is going to be 1.5 times the old force. Or you can say F2 over F1 equals to B2 V2 Q2 divided by B1 V1 Q1. B is not changing, so B2 and B1 are the same, so we cancel out. V2 is, velocity is half the V1, and Q2 is tripled, 3 Q1. So it's going to be, these cancel out, 3 times half is going to be 1.5, so F2 over F1 is 1.5. That's how we find out the ratio.